Hello friends, in this video I am gonna tell you how to solve probability problems using normal distribution. To solve a normal distribution, to solve a probability using normal distribution, we have two assumptions. The number one assumption is the data should come from the normal distribution, and the second assumption is the number of observations in data set must be at least 40, or data size n must be greater than equal to 40. These are two assumptions, and if number of observations is less than 40, then students t distribution is used rather than the standard normal distribution. It is very important because we must know when to use standard normal distribution, when to use the t distribution. Okay, let's consider the first problem. And the first problem states the weights of steers in a herd are distributed normally. The variance is 40,000, mean is 1,300 pounds, and we have to find the probability that the weight of a randomly selected steer is greater than 979 pounds. So I am using manual calculation to solve this problem. Then I will move to the Python to solve this problem. Okay, so to solve this kind of problem, the first step is to calculate z-score. If I am calculating manually, I need to calculate first z-score, and then I will use table or calculator to find the probability. Okay? Using the z-score, I can find the area under the standard normal distribution, and then there are four possibilities of area. The area can be left of z-score. The area can be right of the z-score if we have only one z-score. If I have two z-scores, then area could be between two z-scores and area could be beyond two z-scores. There are four possibilities. If probability statement contains word greater than or at least, then we usually calculate right area of z-score, and if probability statement contains the word between two values, then we get area between two z-scores. Okay, so the area represents the probability for the given events. Basically, we calculate the area under the normal distribution curve, which is usually the probability. Okay, which is the probability, required probability. Let's read the problem once again. Here, let's read the problem once again. The weights of the steers in a herd are distributed normally. The variance is 40,000 and the mean steer weight is 1,300 pounds. Find the probability that the weight of a randomly selected steer is greater than 979 and round your answer to 4 decimal places. Okay, first of all I am calculating manually, and then I will move to Python to show you how to calculate probability using the Python. Okay, here the assumptions are satisfied because it is said that the weight of steers in a herd are distributed normally, so first is satisfied, and the variance and mean weight is given, so we don't need to use like more than 40 or less than 40 assumptions. Okay, so here the objective is to find the probability of a randomly selected steer greater than 979. So z-score is x minus mean over standard deviation, but standard deviation SD is the square root of the variance, which is 40,000. So first of all I will calculate standard deviation, and here I see standard deviation is square root of 40,000, which is 200, and mean weight is 1,300 pounds and x is 979 pounds. Therefore the z-score becomes 979 minus 1,300 divided by 200, which is calculated as negative 1.605. Okay, now we have z-score. In most of the standard normal distribution table, area is usually given for the left side of any z-score, and even most calculator like TI-83 also gives the left side area of any z-score. If I have only one z-score, then it gives area left of the z-score. The function CDF in scipy.stats.norm module also gives the left tail area of any z-score. The following graph will clear this point. Okay, so in this graph I have some z-score value more than negative 2.0, and the area left of this represent the probability z is less than 0. Okay, and this is in the second graph you can see the area is right of some z point, which is more than negative 2 point, negative point is like negative 1.605, and so these two areas represent probability, but the calculator and the table gives the left side area, not right side area. So we have to calculate right area from the left side area. Okay, so entire area under the normal distribution curve is 1, because the probability of a sample space is 1. So we therefore can get area right by subtracting left area from 1. Okay, so if we have one side area, then we can get the area by subtracting left side area from 1. So probability of z is greater than z naught equals 1 minus probability of z less than z naught, that is left side area. Okay, pz less than z naught is the left side area under normal distribution curve, and pz is greater than z naught is right side area of under the normal distribution curve at z naught, z equal to z naught. Okay, so P weight greater than 979, and from that I calculated the Z score 979 minus 1300 divided by 200, which is negative 1.605. Okay, so P Z greater than negative 1.605 equals 1 minus probability of Z less than negative 1.605 here. This is here, and using table or calculator like TI-83, I get Pz less than negative 1.605 equals left hand area of this 0.05425, thus Pz greater than negative 1.605 equals 1 minus 0.05425 equals 0.94575. Hence, probability of weight of randomly selected steer greater than this. So weight of randomly selected steer greater than 979 is 0.9458, correct to 4 decimal places. Okay. Now we have calculated it manually. In the next step, I will calculate this probability using the Python. Okay. Just wait for a minute. Most of Python codes I write most of my Python code in Jupyter notebook. Okay, so here is the Jupyter notebook, and I'm gonna solve that problem in Python too. Okay, to solve any problem related to statistics, I have to import library from scipy library, and I am gonna import that library, and from that scipy module, actually it is a module, not a library. From scipy module, I have to import its stats. Okay, and from stats I have to import a normal distribution, that is in short NORM, norm for normal distribution. So I can type like here import scipy dot stats dot norm as norm, right? So I have written this code here. This line of code will import the library normal distribution library from the scipy module, stats of scipy module, right? So I will run it. Now it is running, and it is just importing the library. So let us wait for a minute. It is running, and now while it is running, I can type something in codes. So scipy.stats.norm. It says there is nothing like that here. Scipy dot, one moment. Actually, we have to import norm from scipy.stats. So it will import scipy.stats from it will import this line of code, import norm, this norm from scipy.stats. Okay, now if I run it, I see this is successfully stored here. Okay, just successfully imported, and now I can use this to calculate probability, to calculate the area. Okay, there is are two functions that are important to calculate probability or z-score, that like norm.cdf and norm.ppf, right? So first of all, I have to write the variable names that can store the given data. So here, the in the question, in the problem, it was given that the mean weight of steer. So I will write mean weight which is given as 1300 pounds, and the variance is also given, so I can write variance which is equal to variance is equal to 40,000, right? So standard deviation is nothing but square root of this one, square root, and we cannot calculate square root directly. We can calculate square root directly too, like this. I can calculate it like 4,000, 40,000 to the exponent to the power or to the 0.5. This is the exponent. If exponent is 0.5, then it means I am getting the square root of 40,000. And I can also use math module from of Python, like math dot square root. There is available here, math dot sqrt to calculate the square root. It will give the same value. Okay, so it doesn't matter whether I am using it or not. So, but I am using here the exponential form, right? So here I've got the standard deviation. Now I will calculate z-score. Z-score is nothing but z-score equals first before writing z-score, I have to give the x value to. X is 979 pounds. Okay, all values are in pounds, and z-score is nothing but x minus mean weight divided by standard deviation. This is our z-score. Now if I calculate the probability, I will use the CDF function from the library, normal distribution library in scipy.stats module. So I will use probability, here PR stand for probability, equals norm.cdf, and I will use this one. This is the, and this probability will give me the left area, not right area. If I run it, you will see that it will give the left area. Okay, not right one. If I print like this one, print probability, print probability is, I will write F for formatted, and probability is I will round it, the final answer to 4 decimal places. So I will write PR, 4 to get it rounded to 4 places. If I run it, I will get here 0.0542, which is the left side area of the of this. But to get the right side area, I have to subtract this 0.0542 from 1, because the entire area under the normal distribution curve is 1. So I will subtract it here, like 1 minus normal distribution, norm times CDF dot z-score. Then this will this line of code will give me the area right of z-score. Z-score is nothing but here negative 1.605. Okay, so I can print like PowerPoint also. If I run it again, I will get here 0.9458. If I run the z-score, like print F, and then I will print z-score equals, and I print z-score, and I will round this to 4 decimals as well. So I'm gonna round this to 4 decimal too. So I will use this 4, and then if I run it, I get it like negative 1.605. Okay, so this is the z-score and this is the probability, and in the PowerPoint you have seen that the probability is nothing but 0.9458. So I can write here in the markdown that the probability the probability that weight of a randomly selected steer is greater than 979 is 0.9458. This is our answer, and I have typed here. Okay, so this is the question has been done in Python 2. Okay, thank you for watching. Have a great day ahead. Bye.